Good day, and welcome to our webcast, Understand and Control Compressed Air System Costs, brought to you by CFE Media and Technology and sponsored by UE Systems Incorporated. Today we're joined by Joe Ghislaine, the principal of Ghislaine Operational Efficiency and a Compressed Air Challenge instructor. I'm Kevin Parker, an editor with CFE Media and Technology. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. To take the Learning Unit exam, use the Learning Unit exam tab option at the top of your screen. The exam will open in a separate browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. Evaluating compressed air systems means more than checking your electric bill. It means taking a proactive look at how, when, and why compressed air is used. The work must address both supply side and demand side management. This webcast will review some proven strategies for better energy management. Stay tuned to learn how to establish the compressed air maintenance management program and execute best practice compressed air strategies, including examination of highest point of use requirements and high volume intermittent requirements. Understanding compressed air systems can decrease costs and increase productivity. You see before you the learning objectives for today's program. The exam will be posted on CFE Media websites with the on-demand version of this webcast. The exam is for one RECEP ASIC Certified Professional Development Hour. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh the browser or click the Refresh Media button directly under the presenter's picture. Control the volume of this webcast by adjusting the volume on your computer or on the webcast platform. For technical problems with audio or slides, click on the question mark at the top right corner of the screen to access system checks to try before contacting an online technician. If a technician is needed, type a message in the Ask a Question box and someone will get to you as quickly as possible. The Ask a Question box is also used to ask questions of our speaker. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded, including the Q&A session. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and additional resources, use the Event Resources tab on the left side of your screen. These documents will also be available with the on-demand version of this webcast. We'll now hear from the sponsor of today's webinar. At the end of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned.
UE Systems has been delivering the highest quality ultrasonic detection instruments for more than 40 years. And now, they are bringing their world-class education right to your desk. Introducing UE Systems Compressed Air Survey online training course. You will be walked through the fundamentals of leak detection, preparation and planning for a compressed air survey, the different types of leaks, the ultrasonic instruments used in a leak survey, and an in-depth look at how to use that equipment. This e-learning course will teach you how to analyze and report your findings, how to log your results into the DMS software, and the corrective actions you should take upon completion of your compressed air survey. The course is broken up into 6 segments with a quiz at the end of each one. After completing the online course, a UE Systems certified learning coach will remotely walk the student through the practical exam performed at their own plant. For more information, contact UE Systems, the leader in ultrasound detection.
Welcome back. I'm happy to produce today's presenter, Joe Ghislaine, Principal with Ghislaine Operational Efficiency and a Compressed Air Challenge instructor. Joe has extensive knowledge and experience in both commercial and industrial facilities and operations, as well as expertise in energy efficiency, energy management, and lean manufacturing, concentrated in the automotive industry and supply chain. He has a demonstrated history of leading teams in improving operations to meet goals, objectives, and saving money. A Six Sigma black belt with an extensive lean training, Joe is a certified energy manager, certified compressed air system specialist, and certified practitioner in energy management systems. Thanks for joining us today, Joe, and the floor is yours.
Thank you, Kevin, and thank you to everyone for joining this webinar, and for our sponsor, UE, and Plant Engineering for putting this webinar on. I think it's important that given the times that we're able to go through and still get together, educate, and be able to go through and do some learning together as we go forward. So thank you, everyone. And again, good morning, good afternoon, good evening to whoever you are from whatever time zone you're calling in on. So as Kevin mentioned, I'm a compressed air challenge instructor. I'm also on the board. I have my own LLC for consulting, and I've got over 31 years experience with Ford Motor Company. And that gives me probably about 40 plus years in plant engineering, energy systems, and both with some commercial and most of the time in industrial. So today we're going to go talk about kind of first go through compressed air challenge and who they are, what they are, and what we're going through and all about. Because again, it's really about the system's performance is an important part of this. So it's a group of all of these people listed from end user, from industrial end users, which I've been the rep on from the beginning, to KGI, distributors, Department of Energy, utilities, consultants. You can see a whole host of everybody that was interested in energy efficiency as well as compressed air. And really they have one thing in mind, and that's to help you with the performance of your compressed air system. So it's really about educating the end user. It's a nonprofit organization, and again, the whole purpose is to go through and do it. And why does CAC care about it? Because in the United States, the DOE says it represents over $5 billion a year in energy cost, represents 10% of the electricity used in North America, and accounts for about 16% of all motor systems. So a large chunk of what we do as far as energy in the United States and in North America goes towards compressed air, and it is really important that we make sure that we use it wisely. And contrary to popular belief, compressed air isn't free. You're talking to production folks and people that use it, they don't think about the cost and everything that goes behind it, but it's a huge cost in compressed air. And it's not very efficient. As you can see from this slide, this shows the amount of horsepower you have to put in on the left. So if you have 1 horsepower motor, compressed air motor on the end, you have to put between 7 and 8 horsepower as input to go through and get that 1 horsepower motor to work. A lot of that is you've got some of the losses that go through from the first to the second bar that goes into the electrical losses and distribution, but a larger part of it is in the actual demand side losses and heat of compression. A big chunk of it's in those losses that you have in the system. So it can be very costly because of that. So at 100 PSI, the cost can range anywhere from 18 to 32 cents per 1,000 cubic feet. In the auto industry, it can be a significant part of the energy. Again, from component plants to stamping plants, 10 to 40%. Leaks can be 20 to 30%. I've seen it, as high as 50, even more, depending on, the type of equipment and whether anybody's doing a leak program at all. And for Ford plants, it can be anywhere from several $100,000 to millions of dollars per year in cost. So the CAC, again, we want to go through and make sure people understand it and the end users know what's happening. It's really about product neutral portfolio. It isn't selling anything, any kind of equipment, anything else. Really, really going through and just understanding how, the effectiveness of compressed air. And DOE did a study that showed that 76% of the end users reported making significant improvements. It's a large amount of energy compared to what was there in the second bullet. And of course, it does yield a good cost when you're going through and doing it. And since its inception, and since we released fundamentals in 1999, we've gone through and trained over 20,000 people. And again, still going strong with updates. It's multi-level training. So it's everything from awareness to the fundamentals, advanced air master specialists on how to do systems and actually go through and meter and monitor, and then best practices. So again, it's a rounded portfolio to help for education. And again, it takes the systems approach and applies best practices. That's the real key is with anything is to look at going through and understanding it as a system. So as we click through these, you'll see that we cover a number of things in the systems approach. So again, the key things we want to concentrate in this one is around the maintenance and demand strategy, which is again that high volume intermittent demands. But I'll also talk about baselining, aligning supply and demand and controls, because with an employee awareness and understanding, because without those, you can't establish what you're doing, how you're doing it, and control it properly. And if you don't get the people involved afterwards, you'll never go through and have sustainable energy efficiency. And the big thing, again, baselining, you've heard this, I'm sure, a lot. If you can't measure it, you can't manage it. You really need to go through and establish a baseline. You have to know where you start to know where you're going and where you're going to end. Going through and develop a pressure profile to see how the dynamics of the system is. So again, we're going through and looking at what the flow and the KW is. We're looking at the system pressure. We're understanding what's happening in the system. And then we can convert that to dollars so we can speak an international language that everybody understands, and really understanding it and putting it in if you're in a manufacturing facility and you're doing it from a cost per widget, it's very, very powerful. If you're in commercial, if you guys go through and do it by square foot or by occupancy, whatever the metric and measurable that you look at for performance and other costs, take and put energy and compressed air in that same thing, because now it puts it on the same level as every other cost structure that's there, and it'll get the attention that it needs. So really the process of baselining, when you want to go through and take it, it's really to understand the effectiveness of your compressors and your compressed air system. And so you're going to go through and do it during normal and different production levels. So that's going to be weekends, holidays, shift to shift, whatever that may be, and whatever changes the energy pieces. Because again, the compressors have to react to whatever the demand is. It's a supply and demand relationship. So if normal production is really high and has one level of compressed air needs, and the other production shifts have a lower level, then things like partial load is going to come into a big play. And of course, seasonal variations, and anytime you change the system operation, and that's not just the compressed air system, that's when you change production uses, and make any model changes that happen. And if you come from an industry like I do with the auto industry, especially in the assembly areas, you can be changing every 2 to 3 years, and some of those major changes in equipment. So when we got to go through and measure it, we really want to look at the power. We want to look at, so you're looking at KW, you're looking at energy, which is KWH, or the consumption. We're looking at pressure. We want to understand what our leak load is. And of course, if we can get flow, because flow is really what does the work. And we want to go through and take measurements before and after any of these changes, especially before changing leaks. And why do we want to do this? Well, we want to go through and do this because, again, we want to establish, did it improve? Didn't it improve? And if it improved, did it meet our expectations or assumptions we made to begin with? And if not, why not? Because again, when you go and look at it, it could be the way the controls are rebalanced, they haven't been rebalanced, haven't been done, those type of things that can go through and still impact that, that you may be able to go through and correct just with some simple adjustments. And that's where we get into aligning the supply and demand, because the whole purpose of this is really to make sure that we drive the system and the supply requirements, and we only go through and use what we need when we need it at the pressure, minimum pressure to still get the job done and the quality level of air you need there. So we want to go through and understand the system requirements, the type of operation in the compressors that drives the number, the duration, the flow, and it may even drive the type of systems that compressors you may put in. The relationship requires that monitoring and control, so understanding what's happening. And really in the end uses, because when we talk about efficiency, we can make a lot of changes on the supply side, but if you still have a ton of air leaks or inappropriate uses, or you're just mismanaging the demand side of it, you're never going to have an efficient system. You'll have an efficient supply, but you'll have a system that isn't efficient at using energy. And that's where the dollars are. That's where the cost is. And so how do we do this aligning supply with demand? Well, we really do this by going through and looking at the compressor controls and how the compressors are being controlled. So that we utilize, it's used to use the right mix of compressors. It's compressor controls brings on the number of running. It shuts off any unnecessary equipment. It delays bringing on the compressors. And it's also used for safety. So there's a lot of things, key critical things that compressor controls do. And again, if you have multiple compressors, you want to be able to go through and tie those compressors together and have them working together as a common set. So when we look at system control, we want to go through and make sure we use the right type of compressors under the right condition. If you have a modulating control screw compressor, it really shouldn't operate between 40 and 50% of capacity, because it becomes very inefficient under that. When we talk about partial loads, everybody switches to variable speed drives. That's the big thing. You get rebates. They're great machines, but you have to remember they should only be used for trim. If they go through and run at full capacity, they're not as efficient. Centrifugal compressors are very efficient base load machines, big machines if you have large loads, but they do have limited modulation. They have a turn down depending on the type of inlet controls, whether it's butterfly or inlet guide vanes. Inlet guide vanes are like 60 to 70%, and the other butterflies can be 70 to maybe 75%, 80% that before they start blowing off. And so it's a condition that you cannot go through, and it basically wastes energy. And then of course, you don't see many of these, but the old double-acting reciprocating compressors were very efficient in part load operations and full load operations. The thing with those always was the amount of maintenance was to keep it up. And so you talk about all of these compressors that I just did. What is the most efficient compressor? Well, obviously it depends on your type of load, and it depends on where you're running and all of those great things. But at the end of the day, the real most efficient compressor is the one that's shut off. So really, when we start talking about controls and what we want to do with energy, we want to go through and shut them off, because if you don't shut them off, they don't save energy. So again, the whole goal here is to reduce demands so we can get to a point to shut it off, and we can control the system so we have a minimum number on at the same time. Maintenance plays a big role in this. Really, it requires proper maintenance from both the supply side and the demand side for proper operation. It's often considered a necessary evil. I've spent most of my career, or I should say a big chunk of my career, in maintenance, dealing with that plant operations, etc. And again, it's often it's considered the most you know, people don't want to spend money on it because it's looked at as, why am I spending money, you know, on something like that? It's one of the first places that budgets get cut. In the auto industry, we were very cyclical, and I always thought it was kind of a bit of chasing, because when you go through and would have high volumes and production was good and you were making money, the problem you had is you couldn't shut the compressors off to do the maintenance. So when the downturn hits and now you have time to do the maintenance, oh, by the way, you don't have the money. So really, it's a balance that's there, and you really have to go through and show where the costs are and why it's costing, because truly it is penny wise and dollar foolish when you look at maintenance in a compressed air system and most energy systems in general. And it's, you know, you've got a lot of losses that go along with it. So an example on the supply side, inlet air filters coming in, or a pressure drop across the dryers and the primary filters, any kind of losses through these, for every 2 psi, it's 1% efficiency. So if you have a 10-pound pressure drop, you're losing 5% efficiency on your motors. Increased temperature and moisture, it increases the drying load, reduces air quality, shortens the life of the equipment, not only on the supply side, but on the demand side. Because if you don't remove the moisture and you aren't able to have good air quality, again, that's going to affect not only the components, but also production itself. Condensate traps, either plugged or leaking, or no trap at all. Those are the things that happen all the time. And the no trap at all is just the open valve constantly blowing. And then the inlet air filters to an air compressor, for every 4 inches of water drop across the inlet air filter, you lose about 1% efficiency. So again, we're restricting the air coming in, which affects the efficiency. And then, of course, the number one is production downtime. When I started as the powerhouse chief at Chicago Stamping, we had old large recips. They were 800 horsepower, double acting recips. They had a total of about 196 hours of downtime a year, and that would shut production down because we were running to the max. So one of the big things I did was set up a PM program, and by the time I left, we were to a point where we were having 0 unscheduled outages. We had one 30-minute unscheduled in about a year, and then we went for almost 1.5 years with 0 unscheduled. So going to total productive maintenance helps a lot. So again, condensate trap. This is a trap that you can see, it's a motor trap, and is it actually working? You have to actually, when you go through and look at this, when they found it, what did they do? They found that the actual tank was full of water, so they pushed the release, and it ran and ran and ran and ran. So again, it is plugged up, it's causing issues. You have to be aware of it. And then you have the other sides of them, where you have ones that aren't no traps at all. They're just blowing it down. They're getting rid of moisture. They need to do it. And in the tanks, these maintenance guys said, hey, I'm tired of this tank filling up. Just don't close the valve. Make sure you don't close it. So that's the solution. But what's the problem with that? It's a big air leak now, so it costs you. So going through and looking at zero loss drain traps and putting in something efficient that really works, and keeping the maintenance up with your drain traps is really important. And again, demand, that's the other part. We just talked about some supply issues. Didn't go into a lot of details with, refrigerator dryers and compressors and all that. That's all. You can find that if you take the fundamentals and advanced courses. This is really to talk about the demands and the demand components, because again, that's where you want to go through and get it. So this gives a typical chart of demand. Production is about 50%. This shows about 1/3 of it in leaks. And then we have another about maybe 15% of it that's in inappropriate uses, and another 15% that may be in the increased demand due to excessive system pressure, and that's called artificial demand. So maintenance losses, some demand side examples. Secondary filters, those plugging up, causing pressure drops. And of course, coupling hoses, tubes, fittings, and disconnects. either going through and being poorly maintained. It's source for air leaks. It also can be an issue when you have pressure drops when you're going through and doing it. The filter regulator lubricators, these can also be big. So again, they're not only ones that can cause issues with air, but then again, it can also cause plugging. It can cause issues with the end use. And if you don't keep lube in the lubricators, it doesn't really help the end uses like it should. Condensate traps we just mentioned, shutoff controls, valves, all of those things, any of that can cause production losses, as well as leakage. And then point of use devices, always cylinders, motors, controls, actuators, hand tools, etc. These can all cause issues because many times, for example, the hand tools, if somebody's not getting a torque on a impact wrench that they've got on the line, what's the first thing the operator's going to do? Crank down the regulator. The fact that the hand tool might be wearing and that the baffles need to be changed, that's another story. So again, it's really about maintenance. So what does this do? And what are the problems it causes? Increased consumption, pressure drops, system pressure losses, and of course, production losses. Production losses are the huge piece of it. So when we look at it, we want to go through and look at those demand side losses because it attacks everything. So it's really unproductive uses for those of you that, that are also used to lean manufacturing. It's just about waste elimination. And that's what energy efficiency and looking at your compressed air system is about. So we want to go through and get rid of that waste, those unproductive demands. So it's leaks, it's inappropriate uses, it's artificial demand, and it's excessive high pressure, high system pressure. Maintenance affects all of these, every single one of them, and leaks is just 100% part of maintenance, but you'll see that it affects every single one of these. The biggest maintenance loss I just meant, air leaks, okay? It causes a lot of problems in a compressed air system, and it's something that's doesn't go away. You can't do an air leak program and just go through and do your ultrasonic leak detection once, and it's not like a project where you can clap, go like this, I'm done, and hey, guess what? We're good to go. Well, no, you're not, because, I talk about it being like an old house. You fix one thing over here and two things over there break, okay? It's the same thing. Yeah, maintenance and equipment, it's ongoing. It's usually something that's an issue because of wear and tear and things that are happening in a plant and facility. So air leaks, they cause the system pressure to drop, requiring a lot of things to go with it. And that's gonna be elevated system pressure, increased compressor operations, higher energy, increased maintenance because you're running the equipment more, and then the purchasing of additional equipment. If you start losing pressure, you start losing production. The first thing the plant manager is going to say is, get another compressor in here. Put on another compressor, do something. And you know what? I've been on that side. Like I said, I was a powerhouse chief. I know for a fact that energy efficiency is very, very important, but nobody ever got fired for using too much energy. Shutting down an entire assembly plant, that's another story. People don't like production going down. So there's that balance. So as maintenance folks, we're going to keep production running, but we also want to balance it with going through and making sure we can do it efficiently. And the leak itself is very costly. Again, when we start talking about the cost of leaks, here's the cost of leaks. This just gives you an example of it. Now, this is 10 cents a kilowatt hour, 100 PSI, typical air compressor running 24/7. This is the cost of what it is for an air leak at that rate. Again, this assumes a perfect orifice. The good thing is even air leaks are inefficient in a compressed air system. So if you have if you have a good copper blowing where you're doing it, it's probably going to be like 0.98. If you have a crack in a pipe or in a fitting, or that you're leaking through threads, that may be something that's going to be less. So that may be 60 to 70%. So again, going through and understanding those values, you don't want to overestimate, but the key here is it's costly. And of course it comes anywhere, anytime, everything. And, the previous one that I did for plant engineering, had the slide about air leaks and being able to hear it. There's a lot of leaks that you can't hear, you can't feel. And it's, if you can hear it and feel it, it's going to cost you about $1,400, $1,800 a year depending on your costs. And so what's the purpose there? Ultrasonic leak detection is an important part of it. And so that's how you find some of these. Of course, the one down in the middle with that nice white wall where you see the oil against it, you don't need ultrasonic leak detection on an oil system if it leaks that bad. You can pretty well find that one. That's a visual. So again, these are all things that are here, and you can see in that bottom corner that those tubes that were there, I did a calculation of it, and they were costing $1,900 per year. And so again, $57 per year for total. Again, it's a large cost that can be in there in small leaks that you're not even aware of or not even looking at. And of course, we repair these air leaks, and sometimes we do it on the fly. And of course, you can see the wonderful repair here. Now, I do recommend that if you're going to go through and do this, you use the industrial strength duct taping. Of course, I'm joking because there is no such thing. And going through and putting duct tape on something, kind of is just like masking putting a Band-Aid on and just masking it, because of it's going to leak. It's pressure behind it that it's not going to hold. So you have leaks that are going to be there that are going to be showing up. So you have to repair them properly as well when you're going through and doing it. And how big is the air leak? Well, with ultrasonic leak detectors, you can go through and you can do estimates. And there's a lot of when the companies give it to you, a lot of them have the software that tells you exactly what's happening and how you're going to go through and do it, and what the actual, where it's at, what the location is, and an estimate on it. If you're not sure, though, you can use the old garbage bag trick. You basically go through and take a 25-gallon garbage bag. You go through and time how long it takes to fill up if you can put it around that leak. And you can go through and calculate how much that leak is. So again, there's some down and dirty, easy ways to estimate when you're going through and doing this. And how do you reduce air leaks, though? It's really truly about maintenance. Again, we get back to maintenance on this. It's an aggressive air leak program that identifies and fixes air leaks. That's maintenance. That's being proactive on going through and doing your maintenance. So the leak tag program, you go through and you establish a reduction leak tag program as an ongoing process. Again, you're going to go through and do this on a periodic basis, and it really depends on how big your system is, what the cost is, and air leaks, and what the cost justification for doing the program is. Then you're going to want to go through and use ultrasonic leak detection to find the leaks. You're going to estimate the cost of those leaks, and most importantly, you're going to fix the leaks. I emphasize that, and everybody goes, "Hey, thanks, Captain Obvious. That's that's the whole purpose." Well, I had a lot of plants that I went to where, when I was the global energy manager at Ford, that they did a great job of going through and putting it in the PM system, logging it in, saying how much it was, going through and putting leak tags out, going through and having PM orders, and they just never fixed them because they couldn't get the maintenance people. They couldn't get the release for the maintenance people to do it. So you have to turn it into savings and show what those savings are to management so you can get the resources to do it. So when you're going through and doing that calculation, that cost of air leaks is very important. So you also want to go through, and after you've done it, you want to establish it as part of your ongoing energy awareness. Again, going through and letting people know how much it costs and what the cost to the company is, or the site or the location, is really important. So the second one that we talked about, the air leaks being the biggest one of those uses that we have. The next one is kind of inappropriate uses. So we, reviewed these with the last seminar, but there are some of them that I just want to highlight because these are really about maintenance as well, and maintenance can impact it. While they can impact all those other systems that we're talking about, these are the ones that seem to be impacted enough, or maintenance can influence. And so what do I mean by that? Well, before we go into that, let's go into the costs, and then I've got some examples. So why do we really care about pneumatic versus electric and switching over. It's really about cost. We talked about the compressed air efficiency, 10 to 15% efficient. So when I'm running a 1 horsepower motor versus a 1 horsepower electric motor, the compressed air, because of the efficiency, is costing me $2,330 to run. That same electric motor would cost me $390. So again, it's key to go through and understand whether you need it. And many times you'll find these inappropriate uses. Why are we doing it? Because that's the way we've always done it. We've always had that as part of production, and nobody's gone back and said, change it, because there might be a risk to it, but there's a huge cost that goes along with it. So to give you some example of just different things for maintenance, this is to go through and blow things clean. So we're blowing off chips in the one. Was the one to the right hand side was a booth that was going through and doing some coating, and they wanted to be able to see the process, so they put these knives on to blow the window clean. Of course, the old down in the left corner, the wand that everybody goes through and uses to blow off dirt, blow off pieces, and just clean the general area, and then the one with the wheel, it's going through and blowing off some dust and dirt into a process as well. So using blowers or using some other method of doing it is really important, or getting nozzles, the engineered nozzles, and putting them on. Temporary solutions. Hey, like I said, maintenance, we're going to keep production going. So we may come up with these temporary solutions to do this. You can see here that we've got them blowing on bearings to keep it cooled, going through and trying to get the aftercooler to give us more air out. So we're blowing compressed air on to cool it down. The upper right is a cabinet cooler that we're talking about, going through and having in to go through and cool the thing so the breakers don't pop. So there's things that's there that we do that we need to go through and make sure that we, if we are doing it, go back and fix it once you fix the root cause problems. Diaphragm pumps, they're used for pumping material and maintenance and a lot of different things. They can also go through and, many times if maintenance thinks that we're not pumping enough, they'll go through and crank up the regulator if there is one. Sometimes they're piped with no regulator, so you're using so much air. And really, when you run those diaphragm pumps faster, they actually don't pump as well. So those can all be controlled and all be done again. And maintenance has influence in it. Vacuums. These are actual vacuums that you go and buy that are run from compressed air. Okay. Back to that cost of compressed air. Going through and getting an electric one, putting it on the floor to vacuum up the stuff for maintenance, that's a whole lot more cost effective than using these. Now, many of them may have been because they thought that it was an area that could be a problem as far as maybe air, maybe chemicals, or maybe some inflammatory materials or anything like that. But when you go through and do it, you can also get ones that are intrinsically safe. Artificial demand. That's the next one I want to tie into a bit. What is artificial demand? Okay, it's increased demand due to excessive system pressure. What causes that? Running at higher pressures due to unregulated air leaks. So any supply air leaks. So again, we're back to that maintenance, and any assumed high pressure requirements. What does that mean? Well, that means that you may have a piece of equipment that is a high pressure application that is a small percentage of the load, but it's driving you to run the entire system that high. And when you go through and run the system higher, what happens to air leaks that aren't regulated? They leak. And even regulated ones, when the regulator's cranked all the way down, they leak more. All of them leak more with higher pressure. The higher the pressure, the greater the leak. So artificial demand is I've got to run those compressors so much more because I'm leaking. And what does leaks do? It lowers the pressure. So what do I have to do? I have to raise the pressure back up again. To do that, I've got to do what? Put more compressors, put more horsepower on. So a supply side air leak, this is just an example of a picture of one. Just, there's many ways of going through and detecting it. This is one that shows a picture of going through and indicating what that is, on a location for it. So we're never really sure what it should be. So that tag may be hard to read, but that little tag underneath it, somebody wrote, do not exceed 60 PSI, yet it's running at 90. what is the pressure really needed, and has the system changed, or is it just that we have things that people need to go through and crank down? Many times it's just a matter of production adjusting it for one reason, and sometimes it's that temporary solution that becomes a permanent, a permanent fix that stays there, that causes these to react. And why is this important? Why are you saying, okay, why are we going through and doing it? Well, for every 2 psi, it's 1% efficiency decrease. So at 10 cents a kilowatt hour, running at 80 psi rather than 100 psi, that would save you $6,500 a year, just changing that pressure and being able to run the system at a lower pressure. Now, this doesn't include artificial demand, okay? When you start including artificial demand, it can be another 0.5 to 1% of efficiency added to that, when you go through and do it. So it can be closer to a 1-to-1 relationship. For every 1 psi decrease, it's 1% efficiency. Again, that depends on how much artificial demand you have in the system. But the whole point is it's very costly to run the system at a higher pressure than you need to. So what do we want to do? We really need to go through and address the requirements. So air quality, high pressure demand, high volume. Air quality, really it's about understanding the pressure drops across it anytime you add something. And the higher the quality, the more equipment you have to add, higher capital, more operating costs, bigger pressure drops through the entire system. So questioning and understanding what air quality is really needed is important. High pressure applications, often a small part of the load is high pressure. The example I had there is I was doing an energy audit in an office building, and that should be just simple HVAC stuff. It should be, maybe needing 20 pounds, 30 pounds at max, because it was a 14-story building. They were running between 90 and 100 on an off-on machine. And the reason is because they had to have that pressure available when the executives came in if they had low tire pressure on their vehicles. So I told them, buy a new one, get rid of it, and lower the pressure. So again, don't let these things drive it. Know what the pressure is. Modify the equipment, isolate it, add a booster, get a different compressor like I talked about, separate it from the system, see whatever you can do to make sure it doesn't drive your system requirements. Because again, that's setting your high water mark, and everything else is there, is now from that, you have to maintain that equipment. So the other one that's always one that hits is a high volume intermittent use. The one that's the most common, or the one we use, for example, in CAC is the bag house or the HVAC filters for dusty environments. Really, it's a high volume intermittent demand. It goes through and happens very quickly, and it uses a lot of air in a short period of time. And what you can do is you can use metered storage to minimize that impact. So going through and calculating the storage, and that's secondary storage to do it. So the primary goes through and dampens the effect on the system. Secondary storage attacks it right at the demand. I'm in more favor of the secondary storage because it attacks it at the source myself. But you can use both of them to go through and help the effects of this. And so understanding what to go through and do. And really the purpose of secondary storage is to take advantage of the time between that intermittent event happening, where you can use that to fill up the tank and handle the thing. And then, of course, you have to be concerned about pressure drop in the system and other problems that can cause it too, because even if you put in primary storage and can't get the air there, it won't be effective. So Woodhaven, this, again, I had in the last one, but it's really the actions they were taking. They did a leak correction form. They went through and reduced the pressure drop in the system. They got rid of orifice plates and replaced those. They tested high pressure requirements that they thought were needed that weren't. And then they had satellite compressors and dryers were removed. The results were they reduced the consumption by 18%. They were able to shut off one 800 horsepower centrifugal, those 6 small booster compressors, and reduced it by 5%. And they saved, 7.9 million kilowatts of energy and over $400,000 a year. Huge pieces of it. Other demand side losses in production losses. plugged filters, had a tandem press when I was at Chicago Stamping, went out to the line. They said, "You're not giving us enough air pressure." I walk out there, the first press being fed off the compressed air line was running slow or stopped, and the rest of them were running fine. It turned out they had a plug filter going into that line. Progressive die, slow pressure. We had line cycle time. The last position I had at Ford I was the North American regional manager for lean supplier optimization. It was a group that went out and did lean in the supply base. So we were doing cycle time losses, and low pressure caused cycle time losses in a progressive die. And the biggest one I've ever seen is the one for Surface Mount Technologies, SMT. That's a printed circuit board. That's how you go through and make printed circuit boards. There were 3 lines going together with one common exit. There had a regulator on the one arm that was going through, and on each of the ends they had an unloader that was pneumatically operated. It actually caused the time to go through and go from 28 seconds to about 24 seconds to about 28 seconds of cycle time. Say, well, that's not too much. Well, it constrained the other 2 lines, and at that line speed over a year, it was $1 million in production losses for it. So huge thing for a small thing as far as maintenance goes. So my preaching here is really, you got to go through and do on compressed air system like you do in production. You got to do total predictive maintenance. You got to go through and do the TPM journey. Get away from the reactive, start going into preventive, predictive, and then make the system proactive. You do that, you're going to go through and have much more energy efficiency, and you're going to have a system that's going to have a lot less problems, a lot less downtime, a lot less production issues due to a compressed air system, just like you would in the production equipment. Again, it's equipment. So regardless of an equipment, using PM is a good strategy to do. And of course, we want to make sure that once we've done this, we make people aware of it. People use compressed air, so get them involved. And you also have people that may not use the compressed air as much, but they're the maintenance guys that take care of the system. They have a better understanding of what it is and what needs to be done, but a lot of times they're not aware of the costs too. So if I told you that I could reduce compressed air usage and energy by buying jackets, hats, keychains, and pizza, would you buy it? So many of you may have seen this last time in the last presentation. I keep it in because it's a time classic, because Monroe Stamping, that's exactly what they did. So this was an hourly led energy team. They talked to the plant manager. They got them to get red coats, red jackets, so they would wear, and they would go through and do an aggressive energy awareness and air leak program. So they would do weekend walkthroughs. They would go through and see what was happening, and they would have their own energy audits. And as such, they gave away buttons, keychains, hats, t-shirts for reporting any energy and getting air leaks fixed. And then pizza lunches for passing the red coat energy audit every quarter. They posted leak boards throughout the plant that showed the progress they were making. And they used the Ford Communication Network. These were all of the TVs they had in the break rooms to go through and send messages. And I did that at the plant I was at too. It was very effective. The results, they reduced from 17.4 million cubic feet a day to 9 million cubic feet a day. The non-production usage was reduced from 5,400 CFM to less than 600 CFM. The electricity was over $2,000 a day savings. And really the biggest thing that happened there was a big culture change, and people cared, and they knew what the costs were. And it was important to them because they were facing competition, not only from their own, from other companies, but also in Ford itself, because again, internally, when you start having to look at some of the programs, you have to be competitive. So really, one thing I found is, as a corporate energy manager, I didn't use much energy. I had to go through and convince other people to do it. So I always said it was like going through and selling ice cubes to Eskimos. With the other 20 things that people have to do in the plant, I'm trying to convince them to do something else as well. So first part of that was the awareness to everybody on what the costs are. And this is a key component. So you want to go through and have a compressed air awareness program that targets the operators, end users, and the maintenance personnel. You want to use site-specific examples. You want to make sure that you have an overview of the system so they understand it. They understand demands, leaks, inappropriate uses. They can see them in their plant. You want to go through and let them know the compressed air is inefficient and very expensive. They are the keys to it being used wisely and, saving energy and money. So they're the ones that need to be part of it. You can develop your own compressed air challenge. I mentioned we put together one as well. And really the keys is for any operating one, whether it's this one or whether it's anything else, you want the operator awareness to go through and hit all the previous items. And in this case, it's customized to the site. You use it for toolbox and lunch talks, 30 to 45 minutes, perfect for team tool meetings, and it's flexible. So, you can deliver it. You can download it, deliver it. You can have help with an instructor delivering it or have somebody deliver it for you. The whole key is it's really to get people to understand, this is a very important part and they are a key part of it. So, and along with this, you want to include this in your awareness piece of it. You want to go through and again, you want to go through and include it in anything you can do when you're talking awareness. So if you have bigger initiatives in a plant and facility, whether it's, ISO 14000, sustainability, cost, ISO 50000, which is the energy management standard, any objectives that you have that you can go through, make sure you use that to your advantage to tie the usage and the cost into that when you're trying to reduce your compressed air and your compressed air system costs. Okay. So again, just kind of wrapping this one up, to maximize the compressed air efficiency, you'll want to take that systems approach. You don't want to go through and do it component by component. For more information, this is just the link for the Compressed Air Challenge website. It has all the training I talked about. There's also case studies, articles, fact sheets. DOE and CAC put together a source book. So there's a lot of good information for people there. Again, the mission of this nonprofit is to educate end users. And for certification, if anybody's interested in that, or if you're going through and going and hiring a professional, you might want to look to see if they have it. This is Compressed Air Gas Institute. They've now started doing certifications. The first is the Certified Compressed Air System Specialist. It really takes all the knowledge from fundamentals and advanced CAC, as well as the KGI handbook and the best practices manual, and it puts it into a certification on somebody that really knows the system. And then the second one, they're in the process of still launching this, but it's the compressed air system assessor. So having somebody come in that actually they're first a system specialist, and now they come in and they know how to basically audit your system. Okay, so with that, this is just my information in case after this you have questions or something pops up, or you just want to, that's something that comes up later. You have a way of going through and getting a hold of me. And with that, I think I'll go through, and it's now time for me to turn it over to Kevin to do the question and answers.
Well, thanks so much, Joe. We really appreciate it. We're going to go to our Q&A now. We have just a few minutes for it. To our listeners, type your questions for Joe into the Ask a Question box now, and we'll get to as many questions as time allows. Questions that we don't get to today will be posted online with the archived version of the webcast. Joe, let me ask you this. You talked a little bit about the right mix of compressors and then went on to talk about rotary screw and centrifugal as two of the types. Now, obviously, most of us know that those are also types of pumps as well. So talk a little bit, is the basic types of compressors more or less the same as the basic types of pumps? And then you have just, dozens of different types that span out from those few. And how do you know which one is the right one for a given installation?
Yeah, that's a great question. So they are very similar. When you start talking about it, the mechanical operation is the same. When you talk about compressed air, you talk about water. It's fluid dynamics. Okay, compressed air is a fluid. The difference is when water leaks, you can see it. Okay, when compressed air, it just makes noise. But for the most part, they're the same. Where they difference is in the dynamics of the system itself and the application of it. When I talk about centrifugals, and you talk about centrifugal pumps, most of the time centrifugal pumps are single stage. And centrifugal chillers are the same. They're usually single stage. When we talk about centrifugal compressors, the difference here is they're multi-stage, because they're going through and taking atmospheric pressure and pressurizing it up to over 100 psi or greater. So they're multi-stage. And the other thing about centrifugals, for example, is they're large machines, usually 300 horse and above. And the reason for that is just the dynamics of them. They have a large bull gear that drives pinions and centrifugal impellers, and they're running 30, 40, 50,000 RPM, depending on the piece of equipment. So they're very sophisticated, and have some different properties. So while the actual fluid flows the same, where you're going through and imparting the energy by spinning an impeller quick, the actual practicality of it and the operation is more sophisticated and a lot more challenging on a centrifugal, a large centrifugal air compressor. But again, the systems are the same. We talk about rotary screws and we talk about centrifugals, because those are the two big ones in the industry. Rotary screw being the most prominent, centrifugals being for the big ones. As I mentioned, the double acting recips, those are pretty well gone. The single acting are still around, because those are the ones that you buy for your house, that you go and buy at the hardware store or home improvement store. Those are the ones mounted to a tank that you do all your work with. So those are still around and still used for controls on a lot of it. So there are different other ones that we talk about briefly in compressed air challenge, like lob, screw, claw. There's a lot that are a lot of like the screw machines. There's a lot of other ones that are specialty ones. We just don't get into it as much because they're not as common, but they do use the similar practices that's there. And how you determine it, when I talk about rotary screws, it can be a load unload machine, it can be a modulating machine, it can be a variable displacement machine, it can be a variable speed drive. These are all control types of actual rotary screws. So the base compressors are rotary screw. Those other things we talk about is the control method and how you control it and what really controls it. And that really determines what the efficiency is. So really what drives the efficiency is the demand piece, and how well it can turn down, and whether it's running at a full load or whether it's running at partial load, what that partial load efficiency is. And another big one is, especially for load unload machines, is how much storage do you have, primary storage, because that can affect the effectiveness of a compressed air control too. So again, if you get a chance, we go through all of that in fundamentals and emphasize how you size it in advance. Hopefully that answered the question.
Yeah, much appreciated. I think you went through it in the presentation, but one of our listeners was asking if you could talk just for a minute about the different levels of compressed air quality and their uses, their industrial uses. But we've only got a couple of minutes to do it, so. Well, we're trying to tell Joe that he's on mute.
Oh, I'm sorry. I apologize. I hit the button accidentally when I was adjusting the volume. So with the real quickly that the what I was saying is on the going through and doing the actual air quality, that's a larger piece of it. There is an ISO standard that goes through and measures what the particulate levels are, moisture levels are, and carbon levels are that you go through. So it's really about liquid, gas, and particulates. That's how you go through and measure it. So that's important. We go through a big portion of that whole section in advanced. So it's really a hard one to do, but you really need to go through and question, because if you ask somebody from production or somebody developing equipment what quality they need, they're going to say the absolute best, of course, and that isn't always the case. So and to do that, you have to put in a lot more equipment to go through and do it. So there's a difference between plant air and instrument quality air, especially if you need oil-free or if you need low moisture. That takes you from a refrigerated dryer to a desiccant dryer, which is much less efficient. Okay.
All right. Thanks so much, Joe. And I want to thank all of our listeners for their great questions. I'd also like to extend special thanks to UE Systems, Inc. for sponsoring today's event. Now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it, because we use this information to improve our webcast. Finally, on behalf of Plant Engineering, I'd like to thank you for attending. This concludes our webcast, and we look forward to seeing you next time.